In our previous lesson, we talked about interval of increase and decrease of a function. In this lesson, we are going to discuss the meaning of local and global maximum minimum. We defined an increasing function on a given interval as follows. F is increasing on the given interval a and b if for x1 and x2 in the interval f of x1 is greater than f of x2 whenever x1 is greater than x2. The graph of an increasing function. We defined decreasing function as f is decreasing on a and b if for real numbers x1 and x2 in the interval f of x1 is smaller than f of x2 when x1 is bigger than x2. The graph of a decreasing function. F of x equals x2 is increasing when x is greater than 0. F of x equals absolute value of x is decreasing when x is smaller than 0. F of x equals 1 over x is decreasing when x is smaller than 0, or when x is greater than 0. Let's define local maximum minimum. We define a delta neighborhood of a point as set of all real numbers between a plus delta and a minus delta when delta is greater than 0. A plus delta, a minus delta. This interval is called delta neighborhood of A. For example, a 0.1 neighborhood of 1 is all real numbers between 0.9 and 1.1. You can say it is open interval from 0.9 to 1.1. We say point A and f of A is the local maximum of f of x if we can find a delta neighborhood of A where f of A is greater or equal than f of x whenever x is in that neighborhood. Geometrically, this point A is the local maximum of the graph of y equals f of x, because in this neighborhood, in this interval, f of A is greater than f of x for all x's in this neighborhood. Similarly, we say point B and f of B is the local minimum if f of x is smaller than f of b for x's in that neighborhood. When the neighborhood exists such that f of x is smaller or equal than f of b for x's in that neighborhood, we say b and f of b is the local minimum of function y equals f of x. point M with the coordinates of M and f of M is the absolute or global maximum of y equals f of x on interval a and b if f of M is greater or equal than f of x whenever x is in a and b in the interval. If we change smaller or equal than to bigger or equal than, then the point would be the global minimum. Let's look at a couple of examples. 0 and 0 is the global minimum of y equals x2 when x is between -1 and 1. If x is between -1 and 1, then x2 is definitely greater or equal than 0. This means f of x is greater or equal than f of 0. Therefore, 0 and 0 is the global minimum of -1 and 1. 0 and 0 is the global minimum of y equals x2 on real numbers, because no matter what x is, if x is a real number, x2 is greater or equal than 0. Global minimum. If we consider f of x equals absolute value of x minus 1 on real lines, then 1 and 0 is the global minimum. F of a, when a is a real number, is absolute value of a minus 1, and it is always greater or equal than 0. Let's have some geometric examples. If the graph of a function is given by this graph, then we have two local maximum, one local minimum, and no global or maximum or minimum. In this graph, we have two absolute minimum and one local maximum. The function does not have an absolute maximum. If you consider y equals x3, there is no local maximum or minimum. If we consider y equals 1 over x, when x is greater than 0, no local or global maximum, minimum. If we draw the graph of y equals negative x plus 1 to the power of 4, the graph is always below the x-axis. Therefore, -1 and 0 is global or absolute maximum, and there is no global or local minimum. Notice that every and each global maximum is a local maximum. Every and each global minimum is local minimum, but the reverse of these statements are not true. Thank you.